Hello, welcome everyone. Let's go ahead and get class going here. Thanks for walking through a blizzard to get here today. I know it's getting kind of nasty out there. Poor timing, unfortunately, because we still have a week left of class left to go, which is kind of where I wanted to start with class today, is just give you some quick updates, reminders about the last few days of class and what's going to be coming up, at least in this class, for the next week or so as we finish up the semester. As you all are probably aware, since you're here today and you've grabbed the papers on the way in, we have an exam this week on Thursday evening. So exam 3 is happening on Thursday evening. That's what we're going to be spending a lot of time talking about today, reviewing those concepts, going over everything to get you as prepared for the exam as possible. We also are going to have our final quiz at the end of class today. So quiz 9 is the last quiz of the semester. In fact, I think it's important to point out that you really only have three ways to change your grade in the class at this point. The quiz that you're going to take today, the exam that you're going to take on Thursday, and then the final exam, which is next week on Friday. A couple of notes about that final exam. We are going to have exam 3 grades posted probably by Monday, I'd say Tuesday at the latest next week. So you will have your exam 3 grade back pretty quickly. And that is important because many of you will probably choose not to take the final exam depending on, how things go for exam 3. So just want to make sure you're aware that we will have those exam grades posted for you. You will know exactly where you stand in the class on Monday or Tuesday next week so that you can, decide whether your grade's good enough or whether you should come in and take the final exam. The other thing that I wanted to mention about the final exam, so this is the last day of lecture. We don't have any more classes next week, right? So we don't have a formal final exam review session, but it's a cumulative exam based off of exams 1, 2, and 3. So all of the review problems, all of the practice problems, everything that we posted for study purposes for the first 3 exams are relevant for the final exam. At this point, if you're taking the final, I would hope you kind of know where your weak areas are. But I will still continue to have office hours next week through the final exam. So if you want to get study help for the final exam next week, I know I'll be having office hours next week. I believe Professor Nuri will also be having office hours next week. I'll let her confirm that at some point. But that is probably your best way to get help for the final exam should you choose to take the final next week. As far as exam 3 goes, just a couple of quick notes before we hop into the review portion of class today. You hopefully know the drill by now. We're going to follow the same process as we did for exams 1 and 2. So it's an evening exam. The room numbers have not changed, so you're going to be reporting to the same room that you've been reporting to for the prior exams. You're allowed to bring a sheet of paper with you with notes on it. However, I wanted to mention one very important thing. We are going to give you a reference sheet on this exam. And I've actually posted the reference sheet to Canvas so you can see ahead of time what we're going to give you to use on the exam. So it's a list of methods it's not a complete list of methods, but it is a partial list of methods that are in the list and in the math class. So this will be part of the exam. This will be given to you on the exam. You don't need to put this on your sheet. In other words, we're going to provide this information for you. I'll even go one step farther and say that you will be able to complete the exam, the lists and maps part of the exam, using this information. You won't need any extra stuff outside of what we give you here to complete the code problems that require lists and maps. So I just want to make sure you're all aware of that before we hop in. Before we take a moment and look over some code examples, I just want to pause real quick and see if anybody has any questions about the schedule that's coming up, the logistics, things like that, regarding the exam and the quiz and stuff like that before we hop in and take a look at some coding problems. Does anybody have any questions about what's coming up the next week or two in this class? Okay. Well, I'll go ahead and get started with the review as soon as it quiets down in here. I know there's still some people coming in as well, so I'm trying to buy a little bit of time to get everybody in here and settled before we get started. Alrighty. One final thing that I forgot to mention before we hop into our review session. Since this is the last day of class, since it is getting to the end of the semester, it is the time of year where we ask you all to fill out your course evaluation. So please, if you haven't done so already, I think they just went out today, so most of you probably haven't looked at the course evals yet. But sometime over the next week or two, please take a few moments. It should not take more than 5 minutes to fill out the course evals for this class. We're always changing. We're always looking for feedback. So appreciate you taking the time to do that. Okay, let's go ahead and move into some reading exercises. You should have grabbed a packet of review problems on your way in. If you didn't, Professor Nuri's back there handing them out to people, so go ahead and grab one. We're going to spend the bulk of class working through these today, starting with the first one on the very first page. Many of these are actually, too, from the review problems that we've already posted. So it's very possible you've already done some of these. But I'm going to work through, hopefully all of them, but as many of them as we have time for. Starting with this problem about the bike that's on the very first page. This is a code reading problem. So it's a problem where we present you some code and you have to tell us what's going to happen. And actually, this part up here, so I like to explain kind of my process, the way that I would solve this particular problem. And so you don't have to do it exactly the way that I do, but I would encourage you to figure out, your own process to solving these problems. I'm actually not even going to bother looking at this stuff first. We'll definitely look at it. We need to solve the problem. But the starting point of this problem is down here, right? So the main method is down here, which means that this is the first thing that's going to happen. So this line of code, line 35, is actually the first one that I am interested in. And what's this line of code doing again? This left side's creating a variable. What's happening on the right-hand side of the equal sign here? Can somebody tell me? Constructor. It's calling the constructor. It's calling the constructor for the bike class. I like to draw a diagram whenever I'm solving problems like this, code reading problems that rely on objects. I like to draw a diagram just to keep track of everything that's happening in these problems. So I would encourage you to do the same. You don't have to make your diagram exactly like I make mine, but I hope you're at least writing down the important pieces of information so you can follow along with these kinds of problems. So going back to this line of code that we're looking at here, it's calling the constructor. What is it about this line that's a big clue that we're calling the constructor here? How do we know it's calling the constructor, Larry? Yeah, the new keyword. I love this. Anytime you see the new keyword, I want flags to go off in your brain that says, oh, I need to add a new object to my diagram. When I see that new keyword, that tells me that I'm going to plop down a circle or a square. It doesn't matter what the shape is, but this is the new object that I am constructing. So this represents the new object that I am constructing. So if we go back and take a look at the code, it's passing in the value of 10. And this is the part now where I'm probably going to scroll back up and look at this code that I skipped past before so that I can make sure that I represent this object properly. You can see that, okay, that 10 is our maximum gear, but there's also an instance variable called current gear, and that's always being set to 1. So this object, after I create it, is going to look like this, where max gear, I'm going to abbreviate just to keep things a little simple, is going to be 10, and current gear is going to be 1. So when I first create the object, this is what it looks like. Max gear is 10, current gear is 1. But I'm not quite done with this line of code yet. I've actually only illustrated this part. We also need to add this part to our diagram. So to incorporate this is a variable, or we also call it a reference. That's another term that we use to call variables that point to objects. This is quite literally just an arrow pointing at the object that I created. So I usually represent that in my diagrams by drawing that arrow like this. And the name of the variable in this particular case is 10 speed. So that's how I would label it. Okay. So everything that I've included here is done as a direct result of this line of code. The right-hand side of the equal sign turns into that circle part, and the left-hand side turns into the arrow that gets created. Are there any questions about what I've done so far? Because we're about to do it again. Actually, if you look at the very next line of code, it's having us create another object. We're calling the constructor. Again, it's a different object, right? So we're going to have two of them now. But we need to do essentially the same thing. I'm going to add that circle to my diagram that represents the bike. Inside of that circle, I need to say what the instance variables are. So in this case, the max gear was 18, and the current gear is still going to be 1, right? Because the current gear, according to the constructor, is going to be 1 for every new bike that we create. That's what the constructor tells us, right? And then the reference, the arrow that's getting drawn here says 18 speed. So that's the arrow that I would draw, which represents that reference in this diagram. Okay. So that one I went through a bit quicker because it was, pretty much the same thing as we did on the first line. And now we get to perhaps some more interesting stuff. We see our first print statement, but inside of that print statement, well, what is this actually? What would you describe this as the stuff inside the parentheses? What am I doing there? In computer science speak. Calling a method. We're calling a method upon what's that vocab word? An instance. So 10 speed is an instance of bike. That's how I would describe that. And the shift up is a method. So I am calling this shift up method upon the 10 speed instance. So what does that mean? We're going to take a look at the shift up code, and we're going to apply this to the 10 speed using our diagram. So this says, all right, if the current gear is less than our maximum gear, and again, I'm looking at the 10 speed, so the current gear is less than our maximum gear, right? Then I'm going to increase the current gear by 1, and then I'm going to return that current gear. So then if I'm trying to keep my diagram up to date, I'm actually going to cross out the 1, right? Because that's no longer valid, and I'll replace that with a new value of 2. That's what the shift up method tells me to do, right? So this is a little easier if you're working with paper and pencil. You can just erase it and write it out. Or honestly, it may not be a bad idea to cross it out so you can see what all the old values are as well. But either way, you need to update this object to reflect the fact that the gear is now 1 higher than it used to be. That's what the shift up code is telling us to do. The return value is the first value that gets printed. So if we're keeping track of what gets printed, the very first thing that's going to get printed is 2. That's the gear that we're on right now. So this line is going to print out 2. Everybody with me on this line of code? Were there any questions about what I did there? How it affects our diagram? All right, let's move on to the next one then. This one says to go do the pedal method. We're still working with the 10 speed, so that's nice. We're working with the same one as before. Let's see what the pedal method tells us to do. Oh, it actually tells us to shift up as the first thing. So we're actually going to go back here, and we're going to shift this up again, which means bumping that current gear up 1 more time. Okay. What happens when the shift up method returns this dot current gear? Where does that value go? Last time we printed it out. Is it going to get printed out this time? Am I going to print out 3? I didn't see a print statement, right? There's no print statement here. There's no print statement, at least not here yet. So actually, this statement, return this dot current gear, is going nowhere. That value is just not being used, at least not at this current moment in time. But on the very next line, it does tell us to print out what the current gear is. So we're not using the return value to do that. We're just accessing the instance variable directly. That actually will print out the value of 3. But I think it's important to understand that it's this line that's printing out the value of 3. We're not using the return value here. I also forgot to update my diagram. This should be crossed out and made into a 3 based off of what we just did. So this is what our current situation looks like on the diagram. We've worked our way through here. We're about to hop into this loop. Does anybody have any questions for me, though, before we hop into that next step? Yes. What's the point of returning the value instead of just making it void? Well, we did use the return value here. So you don't have to use the return value, but I can. In fact, I would say that you're probably using methods a lot of times that are giving you return values and ignoring them. It's pretty common to do. Just because it has a return value doesn't mean you have to do anything with it, but you can if you want to. Yep. So in this case, we decided to use the return value. In this line here, we decided to use the return value, but in this line here, we decided to do it a different way. Potato, potato. In other words, all right, let's take a look at this loop. This loop is going to run 10 times, and it's going to tell the 18 speed to shift up 10 times. It's not printing anything, though, right? I don't see any print statements here. I don't see any print statements in the shift up method. So this loop is not printing anything. It's just telling our bike to shift up 10 times. So if the gear was 1 on our 18 speed and I shifted up 10 times, that should now make it the value of 11. Is everybody with me on that? Anybody confused? Okay. But nothing got printed, so we're still not worried about that yet. However, the next line, I see 18 speed.pedal. So that tells us we have to shift up again. That's going to make it 12. So I'll cross that out and replace it with a 12. Should have made these circles a little bigger, I guess. And then we are going to print out that 12. So at the end of this pedal line, I would expect to see 12 get printed out. And that's because, again, of this line right here in the pedal method. Please raise your hand or holler at me if I'm going too fast, if I lost you. Be happy to go back and re-explain. Not seeing anything, though, so I'm going to move on to our next one that says, okay, we're going to do some printing, and I want to shift down, and there's a number here, 5. So my 10 speed, I want to shift down 5. Let's take a look at what the shift down code says. It says that if the current gear that we're in is bigger than the number of gears that we're, so this is going to be 5 in this case, the number of gears that we're trying to shift down. Is that true? No, it's not. 3 is not greater than 5, right? So that means we're going to jump down to this else statement. In other words, we can't shift down 5 gears because we're only on gear number 3. So we're just going to shift it down as far as we can, which is 1. Put it back in first gear. But let's update our diagram and make sure that we reflect that accurately. I'm going to cross this out, replace it once again with a 1. And that value should get printed out because like we saw before, we're going to go ahead and return it. And we saw that that's going to get plugged into this print statement here. So I'll put a little note to myself over here that I've got the 1. The next line is where things start to get a little bit different. Line 44 here requires some care, requires some attention to make sure we get this done properly. On the left-hand side, I don't say anything too crazy. We're creating a new variable. So I look at the left-hand side, I'm like, oh, are we about to have a third bike here? What do we think? Are we creating a third bike here? How do we know? That new keyword is not here. That new keyword is not here. So we are not creating a new bike. We are only going to have 2 bikes after this. So what is this line of code doing then? If it's not creating a new bike, what is it doing? Well, it's creating a new label. This is a variable name. This is a reference. It's just a label. And specifically, it's saying, make this new label Puffy, and we want it to point to the exact same bike that 18 speed is pointing to. So if we think about our diagram and how to update our diagram to reflect this, right? I'm going to have another arrow pointing at the same one as 18 speed, and it's going to be called Puffy. This is the result of that line of code. I did not add a third bike. I didn't say new, right? I didn't call the constructor. So I don't need to add a third bike. What I did do is I created a third variable. That variable, though, is pointing at one of the already existing bikes that we have. This might seem confusing. I would argue that we do this as humans all the time, right? People have more than one label. Here on campus, you all call me Professor Shook. That's not what my 7-year-old daughter at home calls me, though, right? She calls me Dad. So, Dad and Professor Shook both point to the same person, me. At least for my daughter, right? That's true. So we do this as human beings all the time. It is very possible to have more than one label for the same object. But what are the implications of that? Let's keep working on this problem and see what happens next. Because the very next thing that happens is that it says the Huffy needs to pedal. So we're going to follow that label to the Huffy, and we're going to make it pedal, which says that we have to shift it up by 1. Well, wait a second. Huffy and 18 speed are pointing the same thing, so I'm actually changing 18 speed when I change Huffy. Does that make sense? Anytime I change the Huffy, I'm also changing the 18 speed. Again, referring back to that prior example, right? If I have a birthday, then Dad also has a birthday, because Professor Shook and Dad, right, same person. So if I have a birthday, then that means that Dad also has a birthday. They're talking about the same person, talking about one and the same person, right? So this is going to shift up one more time to lucky number 13. I know it's outside of the circle. I ran out of space. Sorry about that, but it is definitely the current gear. And that's ultimately what's going to get printed on this line as well, is 13. As you can maybe imagine, this is where a lot of students started to make a wrong turn here. If you treat this as though it's a new bike, then you end up getting different answers, right? This is not 2. Huffy is not a new bike. It's a bike we've already seen before. It's the 18 speed, which has already been shifted a bunch of times. So we have to make sure that we reflect that. Whenever we refer to the Huffy, we're actually referring to the same object as the 18 speed. And then we just make things really wacky with this line 46. Well, I'm not actually even creating a new variable here, right? 10 speed already exists. In fact, it's on our diagram. 10 speed represents this arrow that's pointing here. So what is this line of code telling us to do? It's telling us to move the arrow. The arrow already exists. I want to make it point at something else. I'm going to make it point at whatever Huffy is pointing at. So if we wanted to reflect that in our diagram, then I would, erase. Where's my eraser? Right here. I would erase this arrow. This no longer exists. Instead, that arrow labeled 10 speed is now going to be pointing at the exact same thing as the other ones are. We now have 3 variables, 3 bike variables that are all pointing at the exact same object. What does that mean for this circle over here? This poor little circle over here. We have no way of accessing that bike anymore. That bike is basically thrown in the trash. In fact, this won't be on the exam, but just to, clue you in a little bit on what happens to that bike, it gets garbage collected. That is the technical term for it. It gets garbage collected. It gets thrown away. The computer says, we can't, that bike's done. Nothing else is pointing to it anymore, so we're just going to forget about it. Now, all 3 of our variables are pointing at the exact same object. So that means that if I change any one of these 3, the other 2 will also see those changes, right? Because they're looking at the exact same object. So we can finish up these last few lines. You can see that it's telling the 18 speed to shift down 7 gears. Well, it can do that. It's at 13 now, so we can move it down 7. That would take it down to 6, according to the code listed up above. That's what would get printed out as a result of this line. Oops. The line below is trying to shift the 10 speed down 7 gears. Well, okay, we don't have that many gears left anymore because the 10 speed is pointing at the same one as the 18 speed. So 7 is more than 6. the code is going to tell us, well, since we can't subtract 7, we're just going to make it as small as we can, which is 1, which is what's going to get printed out here. And then finally, it tells us to pedal the Huffy, which recall tells us that we need to shift it up first and then print out that new value. So we're going to shift this up one more time and get a 2, which is the final value that I would expect to get printed out here. I would like to actually run this code and verify that I got it correct, but anything that I've commented is what gets printed. So 2, 3, 12, 1, 13, 6, 1, 2 is what I'm expecting to get printed here. Let's run this and see if I actually got it right or if I made a mistake somewhere. It's entirely possible. 2, 3, 12, 1, 13, 6, 1, 2. Nailed it. Nailed it. It's not, it's great that I know it, though. What I'm worried about is whether you know it. Does anybody have any questions? Does anybody need me to go back and explain a step? You are absolutely going to see problems, at least one problem like this, on your exam on Thursday, I promise you. So does anybody have any questions about what I did here, about drawing the diagram, all that fun stuff? Any questions? No? Yes?
You said we won't have to worry about things getting garbage collected?
No. No, that's just a little bonus info for you. Yeah. Okay. I'm not seeing any other hands, so let's go ahead and move on to the next page, which is, I think we got a few more code reading problems here. This one involves math. I'm glad we're getting some map practice today because you're going to see maps on the quiz here in just a little bit too at the end of the day. So this is good quiz practice as well, for that matter. The problem on page 2 is this one right here, but let's chat about it a little bit first before we walk through it. Let's do some review of maps for a second. Maps are a bit different than the lists that we're also going to be talking about, but also the arrays that we've been talking about too. Lists and arrays have certain properties that maps don't have. Can somebody give me an example of a property that I expect a list to have or an array to have that maps aren't going to have? Yeah. An order, exactly right. Yeah, that's the biggest one. It's not the only one, but it's definitely the biggest one, the one that we kind of care about the most. Arrays and lists start at 0, go 0, 1, 2, 3, 4, etc., until they hit the end of the array or the list. Maps don't do that. How do maps store data? What is that called again? It's a good vocab check. Maps don't have an index. They have something else called... It's a pair. Pair of what? Key value pairs. That's right. Key value pairs. So the key of a map, the keys of a map they're not an index, but it's the closest thing to an index that a map has, right? The biggest difference is that a key can be anything. If you really wanted to, you could make your keys be 0, 1, 2, 3. I would say if you really want to do that, you should just use a list, because the list does that for you already. More often than not, you're going to see something like what you see here, where the key, the type of the key, is going to be something that's not an integer. In this case, it's a string. And we're making a mapping from the key to the value. So the important things to remember when dealing with maps are when we put data into a map, I can't just add a value. I have to also have a key associated with it as well. So when we look at this right here, this is the key and this is the value. I have to specify both. This says that the value of x is mapped to the value of z. The value of y is mapped to the value of x, and the value of z is mapped to the value of m. So you could kind of sketch out what this looks like, on your paper if you wanted to, right? I would quite literally, if I wanted to write it out, I would say x is mapped to z, y is mapped to x, and z is mapped to m. I feel like this is a little bit redundant because you can already kind of see that pretty well just from looking at the put statements, right? But if it helps you feel better to write it out a little bit more cleanly, that's totally fine. This is creating a second map. So we have two maps here. Again, if you wanted to write out the mappings for this one, you could. It would look something like this, where Z is mapped to X, P is mapped to N, and finally Y is mapped to M. So these are really just our data structures, and the actual printing and the actual processing happens down here. So we start with the current variable Z. We're going to run through this loop 3 times. Let's ignore the print statement for a second and just focus on this. The get method does what? What am I plugging into this method? Is it a key or a value? What do I plug into .get? A key or a value? Anybody remember? You plug in a key, and it gives me the value. So for data 1, if I plug in a key of X, it's going to give me Z. If I plug in Z, it's going to give me N. Right? I plug in the key, it gives me the value. What if I plug in Q? What would it tell me then? No, that's right. Q is not on my list. Q is not here. Q is not a key that exists. So it would respond to me by saying nothing. I don't have that. That's not here. Null is the computer science term for that purpose. Okay, so getting back to the task at hand, our current value starts at Z. That gets plugged into data 1. So that's going to give us back M, right? It's going to give us back M. So the very first thing that gets printed out is going to be M. Everybody with me so far? All right. Then we're going to update our variable. We're actually calling get again, but on our second map. So I'm taking that same Z that I plugged into the first map, I'm now plugging it into the second map. So when I plug Z into the second map, I get X, which means that my current variable, the next time through the loop, is not going to be Z, it's going to be X. Okay, so when I go through this loop the second time and I plug in X for this line, if I refer back up to this map, it's going to say, oh, X gets me Z. Okay, fair enough. So that'll be the second value that I print out, which would be Z. We now have to plug the Z into our second map. We see that Z gives us X. And then finally, we're going to take that X value and plug it back into the first map up here. X gives us Z once again. So we should print out Z for the third and final time. I feel like I might have made a mistake here, but I'm going to go ahead and run this code and verify whether that's true. Oh, yeah, I did make a mistake. Where did I got the first two right. I screwed up the third one. I felt like that was true, but where did I screw it up? Oh, I'm sorry. Yes, thank you. You explained that perfectly. We needed to plug X into this map. X doesn't exist in this map. Correct? X is not here. So when we plug X in, well, no. I did that wrong still. I'm still a step back. We got M, we got Z. No, actually, that's what's happening. When we plug Z in here, we would get... This would have had to be X. Yeah, so X isn't here. It would have been null. I feel like there might have actually been a typo in this one, to be perfectly honest with you. I feel like this maybe should have been an X instead of a Y. I feel like that was a typo. I apologize for that. That's part of the reason why I feel like, well, it didn't change anything though. What am I doing wrong? All right, I'm just going to start it all over again because clearly I'm skipping a step. We start out with Z. Z gets plugged in. Z maps to M. That's what gets printed out. After we plug in Z here, this becomes X the next time around. So I'm going to write that down this time. We plug X into the first map. That gets us Z again. So we see the Z get printed out. But when we plug X into this map here, I was hoping that we would get an M back out. That's kind of what I was going for, but it's not working. Or it is working, actually. We plug M in here. Yeah, no, this is working. Plug M in here, but M doesn't exist in this map. So when we plug M in here, we get null back out, and that's what we see for the third and final value. Yep. It took my brain a second to catch up there. I apologize for the fact that I struggle with this one a little bit, but again, it's not about me, it's about you all. What if you are struggling with this problem? I want to know. I will happily go through it again, top to bottom, if that would be useful for you. Please let me know if you have any questions or which part of this problem you are confused about. Sorry for the little snafu on this one. Not seeing any hands. Last chance. Okay, since I'm still not seeing any questions, we're going to forge ahead to our next problem, which is going to be from the exam review. It's code reading question 3, part 1. This time we're dealing with linked lists. We're dealing with linked lists. These are nice because, or actually just lists, honestly. I had somebody come to my office hours today and ask me what the difference is between a linked list and an array list, and I want to make it clear to all of you that for the purposes of this exam, they're the same. I don't care. I don't care if you use a linked list. I don't care if you use an array list. Doesn't matter to me. If you know how to use one or the other, I mean, you should know how to use both. If you know how to use one, you should know how to use the other. It doesn't matter to me which one. The more important concepts for me that you understand are that you understand how to put things onto a list. So if this were an array, we use square brackets. Why do we use square brackets here? Why do we do it like this? Why is this the way that we add things to our list instead of using square brackets like we saw with arrays? What's the difference? Yes. I'm sorry? List isn't it? Well, so list is an interface. Linked list, though, is linked list is not an interface, and actually, we haven't talked about interfaces. Interfaces will not be on this particular exam. Linked list is a word that starts with an O that we've talked about so many times. It's an object. It's an object. That actually goes for the map, too, that we just saw on the prior question. Maps are objects, which is why whenever we use a list, a linked list, or a map, we do, what is this called again? See that new keyword, so that means I must be calling the constructor. Yes, I have to call the constructor to use a linked list. I have to call the constructor to use a map. That's what we're doing. This is the new keyword. The parentheses here indicate that I'm calling a method. What method am I calling? I'm calling the constructor to make this brand new map or to make this brand new list in this case. So after we create the list, we add 2 elements to it, and this might be a good time to, again, keep track of what your list looks like. When I add the 4, I know I'm using square brackets here, but it's not an array. It's definitely a list. After I add the 4 and the 9, this is what my list is going to look like, right? So now we just have to figure out what's going on inside of this loop. This loop's going to run 3 times. It's going to first get the size of the list. Did I miss something? What happened? I feel like I'm missing out on something. I don't know what I missed. Okay. The first time through, we get the size of the list, which so far is 2. Here's our good friend modulus that I bet you were hoping you would never see again, but surprise, modulus is still here. So 7 modulus 2 is Oh, that feels like we're going back a little ways. 7 modulus 2 is 1, right? 2 goes into 7 3 times, and there's 1 left over. Modulus is our remainder. So the first time through the loop, this will be 1. Then we're going to grab, this is equivalent, so if this were an array that we're using, we would say items with square brackets, right? But items is not an array, it's a list, which is why we use the get method instead. We call the method upon an instance of the object. So if we get the value at position 0, that's going to be the 4. 4 plus 1 gives me 5. So when I add 4 plus 1 here and stick it into the list, that's telling us to add a 5 onto the list. Everybody with me so far? Do I need to go back through that process again? Because we're going to do it 2 more times. The loop says we have to repeat 3 times. We only did the repetition once, so we have to do it 3 more times. Okay. Second time through the list. The size is bigger now. The size is 3. It used to be 2, but now it's 3. So 7 modulus 3 is... 7 modulus 3 is still 1, actually. Still 1. So then the term at position 1 is this 9. So 9 plus 1 gives me 10, which is going to be the next value that gets added onto the list. Pause here and make sure everybody's with me. We got one more trip through the loop. One more trip through the loop following this process. Okay, now the size is 4. 7 mod 4 is finally something that's not 1, because it is... what? 7 mod 4 is 3. We're going to get the value that is at position 2, which is what? Which value is in position 2? 5. So 5 plus 3 gives us 8. When the loop is finished, these are the values that I expect to be in my list. Does anybody have any questions about how I got there or what that process is? We haven't actually printed out anything yet, but this loop right here, what is that doing for us? We have a word for that. We haven't talked about it in a little while, but it's a word that starts with a T. Used it with arrays a lot. It's a traversal. It's a traversal. We're not traversing an array, but we're traversing a list. And you'll notice that they look very similar. The biggest difference is that it's not items.length. That's what it would be if it was an array. It's items.size, because that's what the method is called. For linked lists, it's called size. And instead of using square brackets to retrieve values from there, we use the get method, which we saw, up above. Anyhow. So since this is the traversal, what do I expect to get printed? This. I expect these 5 values to get printed. Let's run it and make sure that's what actually happens. 4, 9, 5, 10, and 8. Yes. Yes. Any questions? Any part of this? Yes. Line 15, this one here. So this is the equivalent of doing an array access with the square brackets. So, or I guess more accurately like this. This is the list equivalent, and the reason why we use .get instead of the square brackets is because this isn't an array, it's an object. It's a linked list object, and that linked list object has a method called get. In fact, you can see that's one of the ones that is on our reference sheets, right? Lists have a method called get, where I plug in the index and it gives me back the value. Otherwise, it works exactly the same as you would expect an array to. It's just an object instead of an array. Does that answer your question? Yeah. Awesome. Any other questions on this one before we move on to our next review problem? Okay. I think we have one more code reading one to do and then a code writing one to wrap up if we have enough time. This next code reading one, I will say, is probably, I think, the hardest code reading one of the whole bunch, if you ask me. So if you understand how this one works, you're in pretty good shape, in my opinion. Let's take a look at it and see how far we can get. Just like I did for the bike problem. Anytime you're doing code reading with objects, right? Just like I did for the bike problem, I'm going to want to start drawing diagrams to represent what's happening, to make sure that I can follow through everything appropriately. So looking at the code in the main method, which is at the it's actually on the next page if you're following along in the packet. The combo lock definition is on the first page, and then the main method is on the following page, which is what I'm looking at here. This creates an array. This calls our combo lock constructor. So that means that I need to make a new diagram for this problem. Here we go. Let's make a new one. This time I'm not dealing with bikes, I'm dealing with combo locks. But the nice thing is I'm going to do it the exact same way. The only difference is that the instance variables, the stuff that goes inside of the circles, is going to change. It's going to be different. It's not going to be gears anymore, right? It's going to be whatever the combo lock uses for instance variables, which we see that we plug in this array, and we also plug in the number 2 for max tries. Let's refer back to the class to see exactly what's going on here. I've got the secret, this is the combination, max tries, and then there's 2 more actually. It's keeping track of the number of tries as well as the recent try. So what is the most recent combination that I've tried to enter? So to reflect all of that on our diagram, we've got kind of a lot to do, right? The secret is going to be 1, 3, 1. The max tries was 2. Those were the 2 values that we plugged in as parameters to the constructor. Number of tries is just set automatically to be 0, and recent try is just set to be an empty array. So those will be the same for all of the combo locks that we deal with. Number of tries is 0, and recent is going to be all zeros. So this is the object that I created with some abbreviations, but there's 4 instance variables here, right? 4 and 4. Okay. If we go back to our main method here on part 4, we'll see that it's going to call this C4. So the arrow is the other thing that I need to include here. It's going to be C4. Okay. And I have now satisfied everything that needs to happen for this line of code. The next thing that it does is it prints out the combo lock. What happens when I print out an instance like this? What does it refer back to in the class? I heard somebody say it. Yeah. Whenever you print out an object, it's going to look at the toString method and do whatever's in the toString method. Or another way of thinking about that, if this helps you, what I have up here now is equivalent to this. The way that it was written before and the way that it's written right now, equivalent. They do the same thing. They do the exact same thing. No difference whatsoever. Okay, regardless, let's take a trip to the toString method and peek at what's happening there. So we're constructing a string, #, number of tries. That's the first thing that's going to be included. And then this is a traversal over recent try, where we know this to be empty. We can refer to our diagram. We see that it's all 3 zeros. So it's all empty. And then it's going to print that. So it's really just printing out how many times we've tried it and what our most recent try was, which for the purposes of this problem is going to look something like, since we haven't made any tries yet, it's going to be number 0 followed by 0, 0, 0. And I would actually like to verify this one before we move on, just to make sure that I
that we're all on the same page there. Oh, I must have skipped. Where did that C come from? I must have skipped that somewhere. Oh, here it is. I skipped it in the constructor. That's a little sneaky. Sorry about that. I missed that when we called the constructor. C for constructor. So the first thing that we printed out was the constructor. That's my bad that I missed that line in the constructor. The second thing that we print out is very similar to this. I put brackets in. Okay, that's okay. Not too worried about that. We're now on line number 10, where we're going to start to try a solution. So I'm trying to plug in a combination and see if it works. The combination that I'm plugging in is 1, 2, 3. So we can already see before we've run through any code that this isn't going to work, right? This isn't the proper combination. It does not match. It's an important thing to keep in mind as we walk through the code, because I'm going to go to the try solution method, which is right here. It tells me to increase the number of tries by 1. Okay, that's telling me to update my diagram. So I'm going to come over here. I'm going to cross this 0 out. Replace it with a 1. Oof, not there. That's better. So I've now made my first attempt. It's going to print out the number of tries over the max number of tries. You can actually, I kind of already spoilered this one, but you can see that that line is reflected here, where the number of tries is 1 and the max number of tries is 2. And we can actually see both of those in our diagram as well, right? So that's the next line that's going to get printed out there. This line, what's that telling me to do in my diagram? Can anybody explain to me how I would update my diagram to reflect line 28 here? What would I need to do? What's that telling me to change? Here's what my diagram currently looks like. After I execute line 28, what should this look like? What's the value of guess? Well, that's the value that was plugged in as the parameter. Okay, the value that was plugged in as the parameter was this right here, 1, 2, 3. It's saying I want to take that guess and store it as recent try. So to update my diagram accordingly, that means cross out this and replace it with the array that we're currently guessing, which is 1, 2, 3. Any questions about what I did there? Any questions about how this line told me to do that? Hopefully you see why that line prompted me to make that change. If the number of tries is greater than max tries, well, that's not true. So we can fortunately skip all of this. Then we have a loop here. Now, instead of going through this loop line by line, I would encourage you to think for a second, about what this code is and what it's trying to accomplish, right? It's trying to check to see if the guess, the combination that we're guessing, is the same as the secret. So you don't even necessarily have to go through this one line by line. We already know the combination is going to fit, right? We already know that 1, 2, 3, the combo is 1, 3, 1, but the combination that we're trying, the guess that we plugged in is 1, 2, 3. We already know it's not going to fail. If you want to go through that code line by line, you would check the first values and the second values and the third. You can do that, right? But on an exam, it's certainly going to be faster if you can reason about that and be like, oh, yeah, I know that this loop is not going to succeed. Those combinations do not match, which means that we're going to print out the F and get out of here. And we can see there's the F that gets printed out. So everything from the F upwards, it gets us through line 10. Everything from F upwards gets us through line 10. Line 11, though, is going to be running us through the same thing, with the big difference this time being that we can see that, oh, okay, this time I am using the proper combination, right? I'm using the combination that matches. So this time I know that it is going to hopefully succeed, and we can work through this code again with that in mind. I'm going to, once again, increase my number of tries by 1. So let's update our diagram to reflect that. Boop. I'm once again going to update the recent try to reflect the combination that I'm trying. So I'll update my diagram with that while I'm here as well. The combination I'm trying now is 131. And this time as I'm going through the code, all right, so T, number of tries over max tries, there's that line right there. This time I know that this is going to succeed. So this loop will not have to return early. I will get to the G and see the G get printed out, which I do there. So the 2 lines that get printed out for that are the second line that starts with T and then the line that starts with G. And then finally, line number 12 tells us to print out the combination lock again. So the first time we used toString, we got this one, all zeros. But since then, we've tried a couple of combinations. So we can see that when we print out the combination lock after we tried a couple of times, it tells us that we've had 2 tries, and the most recent one that we tried is 131. Again, this is, I would say, probably one of the trickiest code reading problems that we've given to you so far. So if anybody has any questions about this, if anybody wants me to go through any part of it again, I would be more than happy to do that. Now's your chance. Yes, in the back. Recent try being all zeros happens in the constructor right here. In fact, we even left a little note for you to indicate when you create a brand new array of integers, it starts out as all zeros. Yeah. Yep, great question. Any other questions I can address about this problem? So we got about 12 minutes left. I don't know if that'll be quite enough time for us to get through the final problem in the review packet, but I would like to get as far as I possibly can with this one. Since we've done mostly code reading up to this point, I want to do some code writing with you. For this class, so we're asking you to complete a dormitory class, a class that represents a dormitory. You can see the instance variables have been provided for you. So there's 2 options that are going to happen if we ask you to complete a class. One is we'll give you the instance variables that you have to use these. The other option that we might do is we might give you a description of what we want the class and then make you tell us what the instance variables should be. What's the relationship between a class and the instance variables that it contains again? It's a 2-word phrase. It was on a quiz like a week or 2 ago. Has a. That's right, has a. If you see those words appear on the exam, has a, especially if it's on a code writing problem, I want your brain to think, oh, here comes the instance variables, right? Here comes the instance variables. If I say it has a, it says it right here, a dormitory has a. And there's 2 things. There's a name and there's a mapping of room numbers to students. So that means there should be 2 instance variables. And that's in fact what we've given you here. I know that we provided you the instance variables for this one, but it's very possible for us to just give you the description and then say, tell us what instance variables there should be. Should be 1 instance variable per has a. That's the way I think of it anyway. So that has a phrase should hopefully set some alarm bells off. Once you see it on the exam, oh, here comes some instance variables. And to turn things into instance variables, we always use that word private, right? Followed by the type, followed by the name of the instance variable. So our dormitory class has 2 instance variables. This is the name of the dorm, and then this is a mapping where the key represents a room number, and the value, look at this, is actually a student. But it's not just the name of the student, it's the student object. So we're actually directly referencing assignment number 7 when I say student object, right? I believe the I believe the problem actually doesn't mention that specifically, but we did provide you a sort of dummy student object here as well. Keep in mind that that means that we can access anything that is within that student object, right? Not just the name, but also the ID number, or if there's class information. All of that can be accessed via student objects. These are our two instance variables. Let's move down to the constructor. The first thing that it asks us to do is to write the constructor. So if we're writing the constructor, I'm always going to start with public, and then what comes after public? Void? It's not void, actually. If I'm writing a constructor, what comes after public? The name of the class. That's good. The name of the class. The name of the constructor will always be the same as the name of the class. So dormitory. Oops. Helps if I spell it properly. It's saying that for full credit, the constructor should only use one parameter, meaning that when we first create so here's the question, which one are we taking in as a parameter? I have two instance variables, but my constructor is only going to have one parameter. So which one is it going to be? Is it going to be the name, or is it going to be the map? Which one makes the most sense to take in as a parameter, I guess, is the question. When I create a dormitory for the first time, how many students are in there? If I'm WashU, I just built a brand new building, labeled it Shook Hall. Yeah, right. Probably not going to happen. But how many students are in that brand new shiny building that I just cut the ribbon on? 0. None. So I don't need any information about the map. I know that this should be empty. If I just built a brand new dormitory, shiny brand new dormitory, it's going to be empty. There's not going to be any students in it. None. But the name, well, yeah, it should have a name, right? So that's my parameter, string name. Another way of thinking about this, if I chose the map as the parameter, let's say I made the opposite choice. What I'm saying is the incorrect choice. Let's say that instead of bringing in the string name, I brought in, hash map rooms instead. Well, that means that I would have to set my name to be something, right? Like this. But what effect does this have? What does this mean? If I write the name like this, what does that mean for the dorms that I create? What are the implications? They're all named Shook Hall. They're all named Shook Hall, which is not what we want, right? I don't even want that, and I like myself quite a bit. But no, that's not a good choice. So actually, the name is the parameter. Okay. What does that mean for the hash map then? We want this to be empty. The most common mistake that students will make here is they won't do anything for the map. So if you turn in this, you got most of the points for this problem, but you're going to lose some, because the purpose of a constructor is to make sure that all instance variables are properly set. Right now, the hash map, this rooms map, if you had to describe what this rooms map looks like based off of the code that I've written, how would you describe it? It's a word that we've already talked about today, actually. Null. That's right. It is currently null. Can I add a student to a null map? No, I can't. So in other words, we need, this is an object. We need to call the hash map constructor here so that we have an empty map that is ready to accept students to it. So in code, that looks like this. This.rooms is equal to, I'm calling the constructor, so that means I'm going to have new. Then the name of the thing that I want to create, which is a hash map. Since it is a hash map, it requires the angle brackets, although notice I don't actually have to put anything in them here. You do have to put something in them here. but you don't have to put anything in the angle brackets here, but you also need the parentheses because I'm calling a method. I'm calling the constructor. I know this looks a little bit silly having the brackets and the parentheses next to each other, but that is the proper syntax for creating an empty hash map. And this is a necessary step. This is the constructor that would get full credit. If this was a linked list instead of a hash map, same story, actually, except I would say use the linked list constructor here instead of the hash map one, right? Lists and maps are objects. If they are used as instance variables, then I have to call the constructor for them and make sure they exist. So that later on, when I come down here and I create some of these other ones, like add student, this is actually a pretty quick one that we can do, right? I need to make sure that this room number gets assigned to this student. How do I get stuff into a map again? What's that method called again? Put. So I'm going to say rooms.put room number S. Is it S? Yeah, it's S. Boom. That's done. That's the entire method for add student. But going back to what we were talking about before, think about if I didn't have this line, if I forgot to do this, if I neglected to do this, what's going to happen? I create a brand new dormitory. I try to add a student into a room by calling this method, but I never called the constructor for this. So it's known. And the computer's going to say, I can't do that. I can't put a student into something that doesn't exist. So that is absolutely, absolutely why this line is necessary. And I know I'm spending a lot of time talking about it, but that's one of the more common mistakes that I see. So I wanted to make sure to spend some time discussing it. Unfortunately, I don't think we have any more time to go on this problem because we do have a quiz to take. So please go ahead and put your electronics away, put your computers away, your cell phones away. And we'll get the quiz started here in just a moment.